Okay, in this video, we're going to look at the definition of exponential functions and some related formulas. Now, we've had different definitions before, but the one that we're going to use today is that the rate of change is proportional to the amount present. Now, remember, rate of change is a derivative, so we can change rate of change to dy dt is means equals. And when we say proportional to the amount present, that means you can always take the amount present and multiply it by a constant. And you can multiply by the same constant over and over and over again, and that's what creates the exponential growth. So rate of change is proportional to the amount present, or we can just say an exponential function is a solution to this differential equation. So let's solve this differential equation and see what an exponential function would then look like. So that's what I'm doing here. So we start with a differential equation, and I separated the variables. So I put y over with dy, and then I multiplied both sides by dt to get that over here. And then we integrate both sides, and we would get this. Now we want to start solving for y. So if we solve for y, the first thing that we'll do is rewrite it as an exponential. So the base is e. So e to the kt plus c1 is equal to the absolute value of y. And then using our properties of exponents, if we are adding in the exponent, we can rewrite it like this. It's basically using a property we normally use backwards. If you look at this line right here, we're multiplying with the same base, so we could add the exponents, and that would get us here. Now, e to the c1 is just another constant, so I'm going to call that c2. And then if we were to remove the absolute value, that will put a plus or minus on this constant, which is still just another constant. So the solution, general solution to this differential equation is this exponential function. And so we can see that it works. So in general, it's going to be exponential growth if it has this form, and exponential decay if it has this form. And notice the only difference between these two equations is here the exponent is positive, kt, here the exponent is negative. We have a negative sign on it. K is always going to be a positive constant. And then your P naught is your initial amount at time 0. And so the solution to this, the solution to this differential equation would be this exponential, and the solution to this differential equation would be this exponential. Okay, so that's it for this video.